Hello everybody, this is the first video on structure 1 of the new IB chemistry curriculum. And if we see the book or see the curriculum, it is being divided now as opposed to the previous syllabus that we followed, wherein 11 chapters were there and 4 options were there. So some options have been subsumed in the chapters or in the present layout of the things in IB. And as you can see, it is done with the purpose of looking for connections. So as we study chemistry, we will be establishing connections between the two concepts so that one helps to understand the other better. The IB course now has been reduced from the previous one, so everybody studies everything that is there. And in the first section, when we go through the structure 1, 2, and 3, we will find that the basics of chemistry is being developed. The basics are being developed, and they will be then applied to understand the reactivity, which is the higher concept. So structure gives rise to reactivity, and reactivity in turn gives rise to structure. So we understand each other better. As you can see in the layout here, structure 1.1 is introduction to particulate nature of matter. Then followed by 1.2, the nuclear atom, as discovered by Rutherford and then developed by Niels Bohr and subsequent scientists. Then we go deep into the nuclear atom and we see how the electrons are arranged, because if we understand the arrangement of electrons, we will be able to describe why that atom reacts the way it does. Then we have quantification, counting particles by mass. If it's a particle, it will have mass. How many particles will have a mass which is meaningful? That is what we are going to see in structure 1.4. And then we see the ideal gases and the way they behave and compare them to the behavior of real gases. The gases that we encounter in our daily life, nitrogen, hydrogen, oxygen, they are real gases. But the kinetic theory is so laid out that it gives us the concept of an ideal gas. How would an ideal gas behave as opposed to a real gas? So without much ado, let us start looking into this structure 1 in detail. So properties of matter, its particulate nature. Matter is made up of particles, maybe atoms, molecules, or ions or radicals, and these particles are in constant motion. Composition of matter. The classical theory believes that all matter is composed of earth, fire, air, and water, and it was laid down by Aristotle and Empedocles. But this theory could not account for the great diversity and complexity of natural world, could not explain the existence of metals, salts, and gases. It could explain the transformation of substance by, it could not explain the transformation of substances by chemical reaction. and therefore, you see, was lacking in something. They could not explain the properties of matter such as weight, density, color, or temperature. The reason is that it was based on philosophical speculations rather than empirical observation and experimentation. Nobody experimented in those times in which Aristotle or Empedocles lived. They speculated using the knowledge prevalent then to give some ideas. So that was the first formed theory, and that's why it is classical theory. It ignored the role of forces and energy in the behavior of matter, how forces regulate the behavior of matter, how matter will behave as solid, how it will behave as liquid, when it will behave as gases, what are the forces between the particles, what is the energy content of the particles, and why is the energy there. All these things were not answered by the classical theory of matter. But in absence of a better theory that continued to rule till 2000 years, the modeling the particulate nature of matter, a systematic study of chemical changes led to the discovery of many elements that could not be broken down further into simpler substances. It was found that elements could combine in definite ratios with one another, which led to the belief in the existence of atoms. Because if matter is continuous, then it is difficult to imagine how a ratio would be there when two different matters combine. So they had to be particles. Then we would get a molecular formula of some sort. And this thinking, experimentations, observations, and reasoning led to the modern atomic theory. Thus, now it is firmly believed and proved beyond doubt that matter is composed of particles which may be atoms, molecules, or ions and radicals. Matter is composed of particles. Particles of matter have space between them. They are not touching each other as we may imagine them to be. Particles of matter are in a state of random motion. This is due to kinetic energy possessed by them. This kinetic energy is a function of temperature. The temperature rises, kinetic energy rises. Temperature falls, kinetic energy falls, and therefore the motion may become lesser or greater due to the kinetic energy contents of the particle, which is a function of temperature. Can be classified based on arrangement of particles. Elements made up of atoms or homoatomic molecules, pure matter. They are classified as pure matter. Compounds are also classified as pure matter because they are made up of molecules as their smallest particle, and a compound contains only one type of molecule. They are heteromolecular. Atoms are combined in fixed ratios in a molecule. Mixture is impure form of matter made up of elements and compounds, compounds and compounds, elements and elements combining in any ratio. There is no fixed ratio. Therefore, mixture does not have a symbol or a formula. This is a picture showing the similar types of atoms making up an element. Two or more types of atoms have combined to form a molecule. So molecule aggregation is a compound. And we can see here atoms, molecules of different types, atom mixed together in a mixture. There is no particular ratio. Homogeneous or heterogeneous. Elements and compounds are homogeneous. They are made up of one type of particles. It has the same properties throughout because the particles are same. Mixture is heterogeneous in nature. It does not possess the same properties throughout. Its particles are not evenly distributed. Constituents of a mixture can be separated by simple physical means like filtration, distillation, magnet, separating funnel, crystallization, and chromatography. Non-Newtonian fluids. A non-Newtonian fluid does not follow Newton's law of viscosity. Its viscosity changes with the application of stress or shearing force. It can become more fluid or solid. Examples of non-Newtonian fluids are latex paints, soap, polymers, peanut butter, tar, which is used for making roads with concrete. Water is a Newtonian fluid because its viscosity does not change with the application of shearing force or stress. It remains constant. Change of state of matter. Melting is a change from solid to liquid at a fixed temperature. Boiling is a change of matter from liquid state to vapor state at a fixed temperature. Sublimation, solid to gas without melting under certain conditions. Endothermic changes are those in which matter moves from more condensed to less condensed state. Solid to liquid, liquid to gas, the matter will absorb energy, leading to rise in temperature, and that is endothermic process. Exothermic process follows the reverse rule. It is from less condensed state to more condensed state, gas to liquid, liquid to solid. They are examples of exothermic processes. Another concept is that of absolute scale or Kelvin scale. Absolute scale or Kelvin scale. It is not of, it is or. Both are same. Or Kelvin scale. It was proposed by William Thomson, also known as Lord Kelvin, in 1848. The Kelvin scale of temperature is derived from the concept of absolute zero, which is the lowest possible temperature that any matter can reach. And at this temperature, kinetic energy is zero because all types of motion come to a standstill. All types of motions, they come to a standstill. So the kinetic energy of matter at this temperature is zero. The average temperature of the universe is about 2 to 3 Kelvin. Even that is not 0 Kelvin. In our labs, 0 Kelvin has never been achieved. I'm talking of any lab in the world. 0 Kelvin has not been achieved. It's a theoretically calculated temperature using Charles' law. The Kelvin scale is based on the thermodynamic temperature, which is a measure of average kinetic energy of molecules in a system. A few slides back, I had said that kinetic energy is a function of temperature. And from there, it follows that Kelvin scale is based on thermodynamic temperature, which is a measure of average kinetic energy of molecules in a system. All molecules in a system, even though the system is at a particular temperature, will not have the same kinetic energy. Some molecules will have less, some molecules will have more. A group of molecules, a section of molecules will have maximum energy at that temperature. So that is the energy distribution curve. We will deal with it a bit later when we see the Maxwell-Boltzmann curve. He suggested using the Celsius scale, which is based on freezing and boiling points of water. See, these are references. This scale, Fahrenheit scale, and other scales, they are referenced scales. But what did he do using this Celsius scale? It was shifted from 0 degrees centigrade to minus 273.15, which is known as absolute zero, because by calculation it was seen that at this point there should be no motion in any of the particles of a matter. So that absolute zero would be zero on the new scale. Advantage of Kelvin scale. It is an absolute scale, meaning that it does not depend on the properties of any particular substance or reference point, like water, as in Fahrenheit, or in Romer scale, which is now abandoned, and Celsius scale, which is still widely in use. But the internationally accepted unit of temperature is Kelvin. It is directly proportional to thermodynamic temperature, meaning that it reflects energy contents of a system. It is widely used in scientific and engineering fields such as physics, chemistry, that we are studying, astronomy, and thermodynamics. Minimum temperature on Kelvin scale is 0 Kelvin. No type of motion is to be observed at this temperature. Therefore, particles will have zero kinetic energy. At all other temperatures above zero, the particles will be moving and will have some kinetic energy. Kelvin scale does not have negative temperatures as can be seen on Celsius scale and Romer scale or on Fahrenheit scale. Suppose we are dealing with a problem of volume by degree centigrade. And if this degree centigrade equals minus 3 degrees centigrade on the Celsius scale, the volume will turn out to be negative. Volume cannot be negative. Minimum volume can be only zero. Therefore, this caused a problem. And the solution reached by Lord Kelvin was to have a better scale of temperature, and that is Kelvin scale. Now some questions based on structure 1.1, 1.11, 1.1, 1.112, 1.13, 1.14. What factors would you consider to choosing a method for separating components of a mixture? The solution is that physical and chemical properties of components, such as their size, shape, density, solubility, boiling point, melting point, magnetic susceptibility, etc. These properties determine which method can effectively separate the components based on their difference. The type and composition of the mixture, such as whether it is homogeneous or heterogeneous, whether it is solid, liquid, or gas, and the ratio and the amount of components will determine the method selected to separate the components from each other. These factors affect how easy or difficult it is to separate the components and how much yield and purity can be obtained. A solution of 5 gram of sodium chloride in 100 gram of pure water at standard atmospheric temperature and pressure, also known as STP, has the following properties: melting point -3 degrees centigrade and boiling point 101 degrees centigrade. We have to represent this fact, the two facts, that as the temperature rises from -3 to 101, what sort of graph will be expected. So we can draw the graph. In this way. Let this be 0 degrees centigrade. This is not drawn to scale, so let this be -3 degrees centigrade below 0. And let this be 101 degrees centigrade. So the graph will be something like this. Now this is melting. Unless the entire substance has melted, the graph will be flat. Then once the substance has melted completely, then this will increase linearly, and again it will become flat at 101, where boiling takes place. Molecules are separated from each other. The energy, though it is being supplied, will not manifest itself in rise of temperature. The reason is that energy is used in separating the molecules or giving them kinetic energy good enough to overcome the forces of attraction so that they fly off into gaseous state. So this will remain constant, and after the conversion is done, again the graph will rise. So this is the graph which we can draw, and this is not to scale. You can draw the graph to scale by extrapolating the temperature and energy. Energy is, you see, given here on the x-axis. So I hope this will enrich your understanding of the structure 1. And as we understand the concepts laid down here, we will be better able to understand the other structures which are coming up. Now, since we have discussed particulate nature of matter, we will be seeing in the next video the nature of the ultimate particle, that is the atom, which has all the properties of the matter expressed in it. So that is the nuclear atom. Children, wait for 2 days before I do some justice to the nuclear model of atom. Till then, keep practicing, keep studying, keep posting your comments, and subscribe to the channel. Thank you. Have a nice day.